So let's just start the chapter with the definition of the similar figures. But let us suppose if I'm recalling the congruencies rules. So we know that all the circles with the same radii are called as congruent to each other. So whenever we are talking about the circles being congruent, then we can say that two or more circles are said to be congruent to each other if they have the same radii. And this thing is also applicable with the squares of the same side length. So we can say that all squares with the same side lengths, they are nothing but called as congruent to each other. And similarly, if I'm talking about the equilateral triangle, so we know that equilateral triangle are those have the same side length. So we can say that all the equilateral triangle with the same side lengths are nothing but congruent to each other. So if we are talking about the congruency, then let's just talk about the similarity. So what we can say about the similar figures, let's just recall the definition again. Then we can say that two figures having the same shape but not necessarily the same size, they are nothing but called as the similar figures. So this is nothing but the definition of the similar figures, that they are nothing but the figures, those who have the same shape but not necessarily the same size, they are called as the similar figures. So let us suppose if I'll compare this particular definition with the congruency. So if I am taking these circles, so as you can see these circles, so these circles may have the same radii or may not have the same radii. So we can say if I'm talking about these two circles, so I can see over here that the radius of this circle and the radius of this circle is definitely different from each other. It means they are not congruent to each other, but they are similar to each other because they have the same shape. They are circular. That's why they are nothing but called as similar to each other. Definitely they are not congruent because of the different radius. As you can see, the radius of this circle, the radius of this circle, or if you'll compare the radius of this circle and this circle, you can see that its radius and its radius is definitely not equal. So they are not congruent, but they are similar to each other, because the definition of similarity says that two figures are said to be similar if they have the same shape, not necessarily the same size. They are said to be similar figures. So that's why we are saying that all the circles are similar to each other because they have the same shape as they are circular. And now let's just talk about the equilateral triangles. So let us suppose if I'm talking about these triangles, so definitely these triangles are again similar to each other. So we can say that all the equilateral triangles are similar to each other. All the equilateral triangles are similar to each other from the definition of the similar figures. So you can see this, that in the example number 1 where we were talking about the circles, and now we are talking about the equilateral triangle. So they are of the same shape. They are of the same shape but not necessarily of the same size. So we can say such figures as nothing but similar to each other. Now let us suppose if I am taking a journal example, and I am just saying that all congruent figures are similar, but the similar figures need not to be congruent. So what does it mean? It says that all congruent figures are similar, but the similar figures need not to be congruent. We can see this from the previous examples, that all the congruent figures, congruent means those figures that do have the same shape as well as the same size. So if they have the same shape and same size, then they're definitely called as to be similar to each other. But if we are talking about the similar figures, as if I'm talking about the example number 1 in which I have taken the circles, or the example number 2 in which I have taken the equilateral triangles, so from those two examples I can definitely say that they are similar to each other, but they are definitely not congruent because of the different side lengths or because of the different radii. They are not called as to be congruent to each other. So let us suppose if a question arises in my mind that if I have these quadrilaterals, then what can I say about these quadrilateral? That are the quadrilaterals similar to each other or not? So if I'll just look at them, so after looking at them, I can say that these are similar to each other. But definitely, if I just want to justify my statement that whether they are similar to each other, I definitely require some kind of a rule for my justification. So let's just talk about the justification now, that how we can say that, or by following which kind of rules we can say these are similar to each other, rather than just looking at them and judging that they are similar to each other or not. So let us suppose if I'm taking a journal example, if I'm talking about a picture of a monument, let us suppose if I'm taking Taj Mahal. So this is one photograph of Taj Mahal. Let us suppose if I'm taking another photograph. So this is the another photograph of Taj Mahal, and let us suppose if I'm taking another photograph, and this is my third photograph. So as you can see, in all these three photographs, you can see we have the similar monument, means we have the similar Taj Mahal in each and every photograph, but they are definitely of different sizes. As you can see, they are of different sizes, but they are similar to each other. They are same, but they are of different sizes. So what we can say about the similar figures? Similar figures are those which do have the same shape but not necessarily of the same size. They are said to be similar to each other. So after just looking at the pictures or the photographs of Taj Mahal, I can say that they are similar to each other. But let us suppose if I am talking about a particular person and I'm taking a photograph of a person when he was 20 years old. Let us suppose this is the photograph of a person who was 20 years old, and now I'm just taking the picture of the same person who is now 45 years old. So he's the same person, but I have taken the images of the same person in the different ages, 20 and 45. So here you can see that the shapes of the two particular figures, these two particular images are same. The shape, or we can say the size is same, the shape is not, obviously. The size of the photograph is same. So are these photographs similar to each other? So the answer would be like definitely not. They are not similar to each other, because as the size of the picture is same, as you can see, the size of this photograph and the size of this photograph is same, but this is not similar. We can just look if we can just look at these two photographs, then we can definitely say they are not similar to each other. But we can say that over here that these three photographs are similar to each other by just looking at them only. By just looking at them, we can say they are similar. By just looking at them, we can say that they are not similar. So let us suppose if I'm applying all these criterias that I am just taking to judge whether these images are similar or not into the polygons. Let us suppose if I am taking all these judgments towards the polygons, because our main concentration in this chapter is on the polygons. So what can we say at the end about the polygons? So we can say that two polygons of the same number of sides, they are similar if the very first part, that is all corresponding angles are equal, and the second part, all corresponding sides are in the same ratio or proportion. So this is the exact definition that we require if we just wanted to justify whether the two figures or the two polygons are similar to each other or not, because this particular definition would help us to justify our statement that whether the two things are similar to each other or not. So always remember that whenever we are just talking about the similarity, then two polygons, because we are working in the chapter called triangle, so we are saying two polygons of the same number of the sides, because we always compare, or we always take the similarity in between the things that do have the same number of the sides. So we'll say the two polygons having the same number of the sides, they are said to be similar if we have the two things together, all the corresponding angles are equal, and second, all the corresponding sides are in the same ratio. So either condition doesn't satisfy over here. We have the both conditions that are necessary. So always remember, two polygons of the same number of the sides, they are similar if the very first part, all the corresponding angles are equal, and the second part, all the corresponding sides are in the same ratio or in the same proportion. So this is all about the similarity criteria for any two particular polygons. So let us suppose if I am just taking an example of these two quadrilaterals, and I just want to justify that if they are similar, then justify how they are similar. So by the definition or by the criteria of similarity, first of all, I'll start with the very first part. It says that all the angles should be, all the corresponding angles should be equal. So let us suppose this is my first quadrilateral, this is my second quadrilateral. So as you can see over here, this is 105, this is 105, first angle is equal, this is 100 degree, this is 100 degree, second angle is also equal, this is 75, this is 70 degree, this is 70 degree. So this angle is not equal to each other. And further, if I am talking about 85 degree, 85 degree, yes, they are equal. So I can see over here that in the very first part, we just wanted to prove that all the corresponding angles are equal, but here the angle is 70 degree and here the angle is nothing but 75 degree. So are they equal to each other? They are definitely not equal to each other. Why so? Because the angles are different over here. This is 75, this is 70 degree, and let us suppose if this was 75, let us suppose, if I am supposing that if rather than taking 70 degree, I am just taking 75 degree. So if this angle was 75 degree, so let us suppose if I'll write it over here that a slash 75 degree. 75 degree. So let us suppose if I am taking it as a second part. So if this angle was 75 degree, let us suppose if I am taking a second part, if this angle was 75 degree, so obviously this is 75, this is 75, this is 85, this is 85. So first of all, I can say that all the angles are equal. All the angles are equal. If I'll take this angle as 75 degree, then all the angles are equal. But if I'll take 70 degree, then all the angles are definitely not equal. So if I am taking 75 degree over here, then all the angles are equal. This is my very first criteria. And the second one was like, we just have to prove that the corresponding sides ratio are similar. So let us suppose if I'm taking the ratio of these two sides, we have 21, this is 2.1, this is nothing but 4.2. So let's just take the ratio of 2.1 and 4.2. So this is 2.1, 4.2. Let us suppose if I'm taking 1.5 and the ratio of the second one, this is 3.2. And further if I'll take 2.5 and this is nothing but 5.2. And further I'm taking 2.4 and further we have 4.8. So let's just see whether these ratios are equal or not. So I can see over here, this is nothing but into 2, this is nothing but into 2, this is nothing but into 2, this is nothing but into 2. So I can say that all the ratios are nothing but coming equal to each other if I am taking the angle as 75 degree. If the angle is 75 degree, if the angle is 75 degree, so it means that if I'm just taking this particular angle as 75 degree, so my very first condition says that all the angles are equal. The second condition says that the sides are in equal proportion. So it implies that these two figures are similar to each other. These two figures are nothing but similar to each other. But if I am just taking the angle as 70 degree, if I am just taking the angle as a 70 degree, so it means the corresponding angles are not equal. They are not equal. Obviously, the second condition justifies over here that the ratios are same. The ratios are same. the ratios are same, but their corresponding angles are not equal. So it implies that they are not similar, because these two conditions are necessary and sufficient for the similarity criteria. So these two are mandatory. If we just wanted to prove whether the two figures are similar or not. So if one condition doesn't satisfy, it means that this is not similar or these figures are not similar. So if I have taken the angle as 70 degree over here, so it means that they are not similar. Why so? Because the very first condition just does not satisfy at all, because all the angles are not equal. But if I am taking the angle as 75 degree, then all the angles are equal, corresponding sides ratios are equal, so it means they are similar to each other. So this is nothing but the criteria through which we can talk about the similarity of any two particular polygons. So this is how we will talk about the similar figures. I hope the concept of justifying the similarity of any two particular polygon is clear to you.